Welcome to Two Projects. In this video, we are going to explain the project Forecasting National Level Self Harm Trends with Social Networks. Introduction. Self harm involving intentional injury or poisoning, regardless of suicidal intent, poses a significant societal challenge globally. Beyond physical harm, it leads to lasting physiological distress and societal costs. Effective interventions are urgently needed to address its impact on individuals and economies worldwide. The increase in self harm incidents coincides with technological advancements and rapid urbanization, particularly noticeable in developing nations. These shifts bring about heightened stressors and social pressures, contributing to the rise in self harm behaviors. Addressing this requires innovative strategies tailored to contemporary societal dynamics and challenges. But traditional statistical methods for forecasting self harm trends encounter obstacles in data availability and accuracy, impeding timely intervention and policy formulation. Relying solely on historical data may fail to capture the evolving nature of self harm behaviors. Integrating alternative data sources and advanced analytical techniques is essential for more precise predictions. So, the FAST, that is Forecast Self Harm Patterns project, introduces a groundbreaking approach to forecast self harm by harnessing social media signals and employing machine learning techniques. By tapping into the vast amount of information shared on social platforms, FAST provides a data driven methodology that supplements traditional forecasting methods, offering real time insights into emerging self harm trends. Leveraging the capabilities of machine learning, FAST facilitates a deeper understanding of the intricate interplay between individual behaviors, societal influences, and mental health indicators. This empowers policymakers and public health stakeholders to implement proactive interventions effectively. And FAST represents a crucial advancement in addressing the multifaceted challenges of self harm on a global scale. Object of the project. So, as I mentioned earlier, the primary objective of this project is to introduce a novel approach, FAST, that is forecasting self harm patterns, which utilizes social media data analysis to forecast national level trends in self harm incidents. Leveraging user generated content from online social networking sites, particularly Twitter, the project aims to extract emotions and sentiments from posts to create a comprehensive training dataset reflecting mental health indicators. So, the project seeks to train various machine learning algorithms, including ARIMA, SVM, Bayesian Ridge, XGBoost, Random Forest, and CatBoost, using the generated dataset to forecast occurrences of self harm, assessing each model's performance based on metrics such as MAE, RMSE, and MAPE. And by accurately predicting self harm activity, the project aims to provide valuable insights for government and healthcare authorities, enabling them to implement proactive measures such as counseling and support services to reduce self harm incidents and promote mental well being in the population. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is import and required packages. So initially we import essential Python libraries such as NumPy, Pandas, Matplotlib, and sklearn to facilitate data manipulation, visualization, and machine learning model implementation. These packages are fundamental for data analysis and model building. The second step is exploring the dataset. So here we explore the dataset, that is self-harm and mental signals time series data, to understand its structure, features, and contents. This step involves examining the datasets, dimensions, variable types, and summary statistics to gain insights into the data we'll be working with. The third step is data processing. So, shuffling the dataset involves randomly reordering the rows, which helps in removing any inherent biases that might be present due to the original order of data collection. So, this ensures that the data is well distributed and prevents the model from learning any patterns based on the sequence of data points. The next step is train and test split. So, here the dataset is split into training and testing sets to evaluate the performance of machine learning models accurately. So, the training set is used to train the models while the testing set is kept separate and unseen during training to assess how well the models generalize to new data. The next step is training and building the models. So, in this step, various machine learning algorithms such as ARIMA, SVR, XGBoost, Random Forest, Bayesian Ridge, and CatBoost are trained on the training data. So, these models learn patterns and relationships between features and target variables to make predictions on unseen data. And as an extension to the project, in the next step, a decision tree model is employed to enhance prediction accuracy and robustness. Decision trees are powerful models capable of capturing complex relationships in the data, which can lead to more accurate predictions. And as an extension again, a front end interface is developed using the Flask framework, enabling user interaction for testing the trained models. So, SQLite is utilized for user authentication, providing secure access to the application. So, after signing in, users can input feature values which are pre processed before being used for predictions. The trained models are utilized to predict injury and death rates based on the user's input features, and the final outcomes are displayed through the front end interface, providing valuable insights into self harm trends and facilitating proactive interventions for promoting mental well being. Now we'll understand about the algorithms used. So the first algorithm built is ARIMA, that is auto-regressive integrated moving average. So it is a time series forecasting model that works by capturing the linear dependencies between consecutive observations in a time series data. It comprises three main components: auto regression, that is AR, differencing, that is I, and moving average, that is MA. So, ARIMA is well suited for this project because it can effectively model and forecast self harm trends over time, taking into account the sequential nature of the data and potential temporal patterns. It is particularly useful when the data exhibits stationary behavior after differencing, making it applicable for analyzing trends in mental health indicators extracted from social media over time. The next algorithm built is random forest. So, random forest is an ensemble learning method based on decision trees. It combines predictions from multiple trees trained on random subsets of features, reducing overfitting. So, Random Forest is ideal for this project as it can effectively model complex relationships in high dimensional data, providing accurate predictions of self harm trends from social media indicators. The next one is XGBoost, that is extreme gradient boosting. So, it is a powerful gradient boosting algorithm known for its efficiency and accuracy in predictive modeling tasks. It builds a series of decision trees sequentially, where each subsequent tree corrects the errors of the previous ones. XGBoost is well suited for this project due to its ability to handle large datasets, capture intricate patterns in the data, and deliver robust predictions of self harm trends from the rich social media indicators extracted from posts. The next algorithm built is CatBoost. So, CatBoost is a gradient boosting algorithm specifically designed to handle categorical features efficiently. It employs a unique algorithm that deals with categorical variables directly, eliminating the need for pre processing such as one hot encoding. CatBoost is well suited for this project as social media data often contains categorical features, making it effective in capturing the nuances of self harm trends from diverse indicators present in online posts. The next algorithm is Bayesian Ridge. So, Bayesian ridge regression is a probabilistic linear regression technique that applies Bayesian principles to estimate model parameters. It introduces regularization to prevent overfitting and provides uncertainty estimates for predictions. For this project, Bayesian Ridge is suitable due to its ability to handle noisy data and provide reliable estimates, making it effective in forecasting self harm trends based on social media indicators while accounting for uncertainty. And the last one is support vector regression. So SVR maps data into a high dimensional space to establish linear relationships. It aims to find a hyperplane maximizing margin while minimizing residuals. SVR suits this project by capturing nonlinear patterns between social media indicators and self harm trends, providing accurate predictions while handling high dimensional data efficiently. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have required dataset. This is the train dataset and this is test data. So on this train data, we'll train the machine learning models. And on test data, we'll evaluate the model's performance. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. These are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a logon link, click on it. So if you are new users, we have to register first, fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on sign in button. So it has redirected us to the predictions page. So now we have to fill in all these parameters and click on predict button to get the forecasted self-harm results. First, we'll understand these parameters. So these parameters represent various emotional and sentiment indicators extracted from social media data. MS positive and MS negative quantify positive and negative emotions respectively, while MS ambiguous measures ambiguous emotions and MS neutral denotes neutrality. Emmy anger, Emmy disgust, Emmy fear, Emmy joy, Emmy sad, and Emmy surprise represent specific emotions like anger, disgust, fear, joy, sadness, and surprise, respectively. And MNST indicates non suicidal tendencies, and MST identifies suicidal tendencies observed in social media content, providing insights into mental health indicators for forecasting self harm trends. So, now we'll fill in these parameters. So MS positive would be 0.12, MS negative is 0.21, MS ambiguous would be 0.002, MS neutrality is 0.65, ME anger would be 0.06, ME disgust is 0.001. ME fear is 0.01. ME joy would be 0.18. ME sad is 0.4. ME surprise would be 0.009. ME neutrality would be 0.607. MNST would be 0.73 and MST is 0.26. Now click on predict button. So here we can see the result, that is forecasted injury is 56 and forecasted death is 224. So these numbers indicate the frequency of injuries and death within a given population. Click on home link. We'll try giving another set of parameters. So I have entered another set of parameters. Now click on predict button. So here we can see the result, that is forecasted injury is 45 and forecasted death is 239. So similarly, we can give any set of parameters and can get the results. Now click on logout. So the conclusion here is, in the FAST project, we developed a novel approach to forecast national level self-harm trends by harnessing social media data analysis and employing various machine learning algorithms. Our aim was to address the urgent need for timely intervention and proactive measures in mitigating the societal impact of self harm incidents, leveraging the vast amount of information shared on social platforms. So, we employed a range of machine learning algorithms including ARIMA, SVR, XGBoost, Random Forest, Bayesian Ridge, and CatBoost. Each algorithm was chosen for its unique strengths in handling different aspects of the data, such as temporal patterns, nonlinear relationships, and categorical features. The decision tree extension in the project emerged as the top performing algorithm, surpassing others in terms of accuracy and robustness. Its ability to capture complex relationships within the data led to more precise predictions of self harm trends, enhancing the effectiveness of our forecasting methodology. So, for testing and deployment, we developed a user friendly Flask interface that allows users to input parameters related to self harm indicators. The system provides accurate predictions of injury and death rates based on these inputs, enhancing accessibility and usability for stakeholders, including policymakers, healthcare authorities, and the general public. Overall, the FAST project benefits society by providing real time insights into self harm trends, enabling policymakers to implement proactive interventions aimed at reducing self harm incidents and promoting mental well being in communities.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.